The Haitian earthquake of 2010 completely devastated not only the buildings of Port-au-Prince, but also all of the infrastructure systems. As civil engineers for the Princess Foundation Urban Design Team that was commissioned by the government of Haiti, we were tasked with conceptual designs and cost estimates for replacing the infrastructure. We looked at 3 different scenarios, and the first one was in looking at the entire urban core, if I can, of downtown Port-au-Prince, and completely and immediately replacing all of the infrastructure in that immediate core, and the price tag for that was to be $221 million. The second scenario was to look at just a corridor at a time, and the cost for that was $36 million. Then we looked at the scenario of doing 1 block at a time, and that is, what would it cost to provide self-contained and secure infrastructure, including power, water, wastewater, and drainage for 1 block at a time, and that would be including the perimeter streets, and that was $5 million per block. So we did a lot of number crunching and comparing scenarios, but in summary, the core scenario was the $221 million. The corridor at $360 million per corridor would total up to $36 million per corridor would total to $360 million per for the entire project area, and for the block it would total up to $633 million. Now the preferred scenario was the block scenario, despite these vast differences in total cost. And what it included was this, what we call the green machine in the center that provided all of the infrastructure for that block. And there's about 300 units there. Now the stakeholders liked this scenario because they had trust issues with trusting their vital infrastructure services to a sometimes sketchy government. They also liked the idea of the block as an increment that could be self-organized. And additionally, they thought that the ability to secure the perimeter of the block was an essential attribute of that plan. Meanwhile, far away in Saudi Arabia, the city of Mecca is experiencing extreme growth pressures and severe housing shortages. And as a member of a DPZ-led team that was commissioned by the city of Mecca, we worked on designing distributed green infrastructure systems for a very large regional plan. This 100 square kilometer addition to the city of Mecca is designed to accommodate a population of 1 million people within 20 years. And the water supply for this area is desalinated water from the Red Sea that is pumped dozens of kilometers uphill to get to the city. And the conventional wastewater treatment is for all neighborhoods to pump their wastewater to a central treatment plant, and then dump the treated water in the what's called a wadi, or a dry creek. What we proposed was neighborhood treatment plants that would treat the wastewater locally, and then it could be reused in the neighborhood. So here it is, the desalinated water is used only for potable uses. The wastewater from those potable uses goes to a local treatment plant where it's treated and then returned to the neighborhood in a second pipe system for use as in toilets, laundry, and irrigation. This results in a 55% reduction in the use of desalinated water. We developed a rainwater harvesting street that would further enhance the water cycle. This is an inverted crown street that has bioswales at the edges and a French drain in the center that infiltrate the rainwater to recharge the aquifer. Also, this inverted crown street has enough hydraulic capacity to obviate the need for expensive drain inlets and pipe culverts. So in this cutaway view, you see the dry utilities at the edges, the two water pipes, the sewer pipe at the bottom, and the French drain in the center that actually can be built quite inexpensively because it occupies the same trench that was dug in order to install the sewer pipe. Now, any rainwater that doesn't infiltrate into the aquifer can actually trickle down to the treatment plant where it can then be treated and reused in the neighborhood. Now, this rather distorted image here is a stormwater hydrograph that shows that conventional pipe and dump infrastructure results in large increases in runoff, while the rainwater harvesting streets actually result in a 75% reduction in both peak runoff rates and total runoff volumes. The conventional drainage system with drain inlets and pipes would cost 6.7 million Saudi Riyal for 5,000 meters, while the rainwater harvesting streets would cost 1.1 million, which is a savings of 83%. So, in summary, the green infrastructure distributed system results in desal consumption, reduces desal consumption by 55%, provides abundant irrigation water, replenishes the aquifer, prevents flooding, and reduces infrastructure costs. And this Google Earth image shows the first neighborhoods under construction. Thank you very much.